For example 2, we're given two tables below, looking at the average or the total cost of gas at certain gas stations based on the number of gallons purchased. We're asked to calculate the average rate of change at each station and interpret the results. So this is not going to be like all the same day, all the same price. So it's going to kind of vary. Now, average rate of change, when we're talking about that, we're going to talk about the slope between first and last points. So we're only going to be able to use the points that we have here. So in other words, looking at the blue table, I would call that, I don't know, we can call this company A, and we'll call this one company B over here. Company A, we're going to use these first and last data points as our information. Now, in this case, it's kind of like our gallons of gas is like our X and our cost is our Y. It's because how much gas or how much things cost depends on the gallons of gas. So what we're going to do is we're going to take the slope, thinking about the slope equation. We're going to take the y2, which will be the second one, 51.47, minus y1, in this case, would be the cost of 11.32, divided by our x2, the 14.1 gallons, minus our x1 of 3.1. When we simplify that, we end up with 40.15 over 11. We can type that into a calculator, and it's going to give us about 3.65. Now, putting this into context, let me zoom in a little bit. This is a cost, specifically a cost per gallon. So, on average, of all these prices, going from the first price to the last price, we're saying it averages about $3.65 per gallon. We're going to do this similar, or use the same type of information for company B, looking at these two data points. So, we're going to do 34.78 minus 15.91 over 9.4 minus 4.3. Cleaning that up a little bit, we end up with 18.87 divided by 5.1. And when we plug that in, we end up with exactly 3.7. Now again, since we're talking money, let's go two decimal places. $3.70 per gallon. So on average, company A, the blue table on this one, ends up having a cheaper price per gallon. Now, sometimes we'll be given information in a different form. So say, for example, you're given a graph and you're also given a table. These are for two different teams. So we're looking at the points scored for a football team, total points over a certain number of games. We've got the aggressive armadillos and the belligerent bobcats over here. We're going to do the same type of thing, but in this case, we're going to take different information or same information from different types of presentations. So on our graph for the aggressive armadillos, our slope is going to be 229, that's the height at the last point, minus 24 over our x value, in this case our independent value, would be 10 minus 1. Cleaning that up a little bit, 229 minus 24 is 205 over 9. When you type that into our calculators, 205 divided by 9, we end up with, well, I guess I'm going to have to round it. So let's make it 22 point, it's 77777, 78. And then same thing for the belligerent bobcats. This is our last data point. This is our first data point. Our first data point here. So we're going to do the same type of thing. We're going to do 242 minus 28 over 10 minus 1. 242 minus 28 is going to give us 214 divided by 9. 214 divided by 9 gives us 23.777, so 23.78. And that just means, on average, the Bobcats scored more on average. Now, in this case, you probably could have figured that out based off of after 10 games they had more points. But it's nice to be able to back it up with some actual solid calculations. For example 4, we're kind of throwing it back a little bit. We're asked to identify the end behavior of the functions below. So kind of looking at these functions, f of x equals 4x squared, and the other one's g of x equals x to the third. So our degree here is 2. Our leading coefficient is 4. So we have an even degree with a positive leading coefficient. It's been a while since we've thought about end behavior. But with an even degree, that means they're either both pointing up or both pointing down. we're going to say as x approaches negative infinity, as it approaches the left side of the graph, f of x approaches positive infinity. It's going up on the left side of the graph. On the right side of the graph, as x approaches positive infinity, the graph is also going to be pointing up. F of x approaches positive infinity. So both sides of that even graph are pointing up. For g of x, we have a degree that is 3, so that's odd. And we have a leading coefficient of 1, which is positive. So odd degrees go in opposite directions. Positive always means up and to the right. So if they're in opposite directions, that means the left side is going to be going down. So as x approaches negative infinity, in this case, g of x is going to be pointing down. This graph in general, well, looks like a good old parent cubic function. So we're going to say the left side's pointing down to negative infinity. The right side, as x approaches positive infinity, g of x is pointing up and to the right. So we're going to say approaches positive infinity.